This is the third part. We will be discussing about the matrix representation of these gates, so we can actually use them into our coding scenarios and get the main idea about the gates we use in quantum physics. So this actually is more about the intuition of classical computing and the quantum computing. So in classical computing, we have two bits, 0 and 1, and you don't have to go in multiple spaces at the same time. So in quantum computing, you have both of them at the same time. To compute both of them, that's why we have two events. Okay, event 1 and event 2 decided by phase shift. So we have both of them at the same time, but you have to get a single answer in the end. So both of them are computed or controlled by their phase shift. So I'm using this diagram again, and we have this as Hadamard gate. And Hadamard gate is actually the most important gate in quantum physics, and it is used to open the interference and close the interference. What this actually means is that if you have a bit or a thing or a state in at one position, what you actually do is you divide it into two parts. You give a 50-50% chance on both sides. So that's why we have 1 over square root 2 on every side, or you can say that we divide it by 1 over square root 2 with the whole matrix in the start to actually have two different outcomes. So if you have two states, you define two states with this thing. I'm writing this here, 0 0, both states are 0 0, or 0 1. I will not go deep into this in the first lectures, because this is a very important concept. But you have to get the intuition that you have a 100% probability or in one state, but you actually divide it by square root 2 to get into other states. I'm not going to discuss the gates here right now because they are based on another lecture, and they will have another lengthy lecture defining what gates are. So right now I'm actually going to tell you about the representation in matrix form. So this is actually representation of the interference gate I actually showed you before. This is the matrix representation. So if you take 1 over square root of 2 common from this matrix, you actually get this, and this is the main part. If you take 1 over square root 2 common from this part, you will actually get this, and this negative part shows the other part. You can actually write it here as well, but you have some different representation, so you have to stick with them because they are actually used by scientists from a long time. And then you have phase shift alpha phi 1 and phi 2, and they are actually represented on the diagonals of a matrix. And then we have non-diagonal part because we don't have anything else on non-diagonal part. So we show it as a matrix here in this form. And then we have another Hadamard gate, which is used to close the interference. Open it, we have a start of the event, you open the interference, go through the phase shift, and then we close the interference and get our desired or required outcome based on how we do the phase shift. And there we have this diagram, there we have this matrix. This is the required answer. We actually did this before, but we were not on the more of the phase part. That's why we didn't do this. This is the matrix part. I think you cannot see it from this far. I will try to speak upon, so you can actually get the idea. This is E iota phi 1 plus phi 2 divided by 2. So what we actually do here is we multiplied all of them like we did before. We multiplied them, and then we get this idea. Not only we multiplied them based on addition of probabilities, which we actually defined before. So then we have cos phi by 2 iota minus iota sin phi by 2 cos phi by 2 minus iota sin phi by 2. So I'm not going to do this multiplication here because it will get a lot of length here. So I have to fill the whole board, which will actually make the lecture lengthy. So I don't want to do this. And you can actually do this on your own if you want, or you can actually put them in ChatGPT and ask it to multiply it based on quantum interference gate. So it will actually show you the whole multiplication process. You can see it. And then we have the golden representation. This is known as golden representation. So we have a gate here, and then we have interference, and then we have gate. So in more of like working environment in like we work on quantum physics, quantum computing. We don't actually do the maths. We actually do this on paper only. So in the working environment, you actually use the representation of gates, and then you use the phase representation, and then you use the gate representation to get your answer, which is quite similar to this one. But this is the main representation part. And I think that's it for this lecture. Next, we will go into the diagrams and matrices and how they are represented in this form, and then we have different gates. So this that's it from this lecture, and this was only about telling you the representation from this state, from this representation to this representation to this representation. We have 3 different ones. They were actually used by like old scientists, and then we have this one for the maths calculation stuff, where you actually want to do the maths behind it, and this was to show representation when you are actually teaching in a class or stuff. And this one is actually used in the working environment, where you actually have to like drag and drop the gates and simulate them in the environment. And that's it from this side. And most importantly, the main idea behind this is not the maths. These lectures are all about getting the intuition behind the core concepts. These starting lecture will be boring, and they will not be about quantum entanglement, quantum teleportation, quantum cloning, these kind of concepts. They are really fascinating, but they will be more about giving you the build up to understand. Like if I directly go and write these kind of equations like this, like if I'm going to write this, and this is this, and this 1 over this, and this multiplied by this, and then we add the cos phase shift. You will not get the idea that what is this, like what is this, and why are you getting this into this. So you have no idea. They are actually telling you the entanglement part, but to understand this part, you actually have to understand what is going behind this part. So these are bases, and they are important. So that's it. Good luck. Bye.